Hi everyone, I'm Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today we are going to start a new important topic in applied machine learning called model evaluation. So far we have learned how to build machine learning models, but building a model alone is not enough. For example, suppose we build a model to predict house prices. How do we know whether the predictions are good or bad? So that is where model prediction comes into the picture. So today we will understand why we need to evaluate a model and how we can measure its performance. So before starting today's topic, let us quickly recall what we already know. So when we build a machine learning model, we need to answer five important questions such as why do we evaluate the model? How do we measure its performance? And is that model accurate and reliable? How do we compare two different models? Is the model suffering from underfitting or overfitting? Keep these questions in mind because today's entire topic is connected to them. So here, this slide shows the three objectives. Understanding the importance of model evaluation, learning as MAE, MSc, RMSc, and R square, and selecting reliable models for real world predictions. Here, what to say, by the end of the session, you should be able to explain what model evaluation means and why it is important. And we will also learn some important evaluation matrices like what is this mean absolute error, mean squared error, root mean squared error, and R squared score. Finally, we should be able to identify which model is more reliable for making predictions on real world data. Here, understanding the scenario, let us take a simple example. Imagine that Amazon wants to predict delivery time of an order. So that model predicts that the delivery will take nearly 3 days, but the actual delivery takes 6 days. Can we say that the model is performing well? No. So we need to compare predicting value with the actual value. So this leads us to three important questions. Here, how well is our model performed? How close our predictions to the actual value? How does the model generalize to new data, that is unseen data? So suppose a student studies for an examination and predicts that he will score 90 marks, but he actually scores 50. Similarly, machine learning model also needs to be evaluated based on its predictions versus the actual result. And this lead shows the come to the model evaluation is the process of measuring how well a machine learning model performs. We train the model using training data and then test it using data that the model has not seen before. So here the important point is a good model should not simply memorize the training data. It also perform well on new data, that is unknown data. This ability is also called as generalization. Here come, let us think machine learning engineer. Suppose I have two models. That is model A prediction error has a 5 and model B it predicts error such as 15. Which model would you choose? Yes. Model of you will choose model A because its error is lower. So evaluation matrix helps us make a decision instead of simply guessing which model is better. Here, model ideas such as here here key ideas behind this good quality data leads to a reliable model, and then learning. Here, model learn relations between multiple inputs and the target value, that is the independent variable and the dependent variable. And generalization means model performs well on unseen data. And interpretation means coefficients of the impact of the each input. Further, you have to calculate the loss function, which is actual value minus the predicted value. And the error, there are many errors, or means you have to calculate the cost function of that function. So, and then automation, which may be by the help of scikit-learn. Then implementation of model evaluation. Here in first step we need to data preparation. That is, we have to real change real world problem into a machine learning problem model, and then train the model. From this one we have to select which type of model have to be trained, and then make predictions and evaluate using the unseen or new data which is not already learned in a training model, and interpret the results. By the end of the model interpretation, after that we have to evaluate these one of these matrices like MAE, that is mean absolute error, mean squared error, root mean squared error, and R squared score. And based on these values, we should make a better model, better prediction, better decisions. And the purpose of model evaluation is accuracy, precision, recall, and score. Effective evaluation leads to better decision and to the real world impact. So this is the workflow of model evaluation. And this shows the applications of model evaluation as used in healthcare, spam detection, and then e-commerce, finance, transportation. So model evaluation helps organization choose reliable models for real world decisions. So this was the today's summary of knowledge map. We saw about why model evaluation is important, what is the purpose of model evaluation, what are the matrices in model evaluation, what is the workflow of model evaluation and its applications. And then takeaway key is a machine learning model is useful only when it performs reliable on data it has not seen before. Thank you students, catch you in another video.